Picture this. You're staring down at your Cambridge Biology 9700 exam paper. You know the textbook definitions inside and out, right? You write down literally exactly what you memorized about muscle contraction. But then the results come back and your grade boundary just slipped away because of one tiny, almost invisible mistake. And let's be honest, there is absolutely nothing more agonizing than losing a hard-earned grade over a silly technicality before you even realize you've made it. Well, welcome to this explainer. Today we're going to master topic 15.1, neuromuscular junctions, the T-tubule system, and the sarcoplasmic reticulum. This topic pops up in every single examination series, and I'm going to show you exactly what those examiners are actually looking for. So imagine writing a beautifully structured, scientifically accurate description of a neuromuscular junction, only to get hit with a giant, painful, red 0 marks. Why on earth does that happen? Because giving generic answers without linking them directly to the specific scenario in the question is hands down the classic biology mistake that just completely destroys your score. The principal examiner reports literally screen this every single year. Answers that aren't specific to the context provided get 0 credit. It doesn't matter how much biological knowledge you dump onto the page. Context is absolutely everything.
Section 1. Core Principles of 15.1.
To avoid that generic trap, you really need to understand that Cambridge examiners don't just want superficial breadth, They demand analytical depth. The very top candidates use cross-topic connections to prove real conceptual understanding. The neuromuscular junction, it isn't just an empty gap. Think of it kind of like a high-stakes relay race handoff. It's the precise functional connection where the nervous system physically forces the muscle fiber into action. The whole theoretical architecture here rests entirely on these precise definitions and causal relationships. If your exam answer doesn't clearly establish cause and effect, how the arrival of an action potential literally triggers the next sequence of events in the muscle, you are definitely leaving marks on the table. Okay, let's dive into this. Let's talk about the T-tubule system and sarcoplasmic reticulum. I want you to think of T-tubules almost like an internal subway system. The electrical signal doesn't just run along the surface of the muscle. It dives deep underground through these interconnected tubes, hitting the sarcoplasmic reticulum to instantly flood the area with vital calcium ions. Examiners really want to see that you understand this internal spatial relationship. They don't just want a memorized list of random organelles.
Now, understanding these biological structures is really only step 1. In just a moment, I'll show you the hidden examiner clue that changes an answer completely. But first, we need to set up the analytical framework that makes that clue absolutely obvious when you're actually sitting there in the exam hall under pressure.
Section 2. The method mark strategy.
Cambridge examiners are pretty unique because they award crucial marks for the analytical process itself, not just your final answer. If you have the right process, you pick up method marks, even if a final calculation goes slightly off track. So the crucial point is systematically following 5 exact steps. 1. Deconstruct the question. 2. Extract the relevant data from the stimulus materials. 3. Select your analytical framework. 4. Execute your analysis with clear notation. And 5. Present it with the correct terminology. If you process every single 15.1 question through this standardized sequence, you're going to safeguard your grade.
And this builds seamlessly into your experimental skills framework, because you aren't just memorizing here, you're actively doing science. First, you set up your experiment by selecting the appropriate apparatus. Then, you execute by following sequential instructions really carefully. Next, you analyze by making accurate observations. And finally, you evaluate those findings to identify anomalies and draw solid, evidence-based conclusions. Mastering this procedural flow ensures you capture literally every single practical skill mark available.
Section 3. Top 3 examiner warnings. Now, even with the perfect framework, students still fall into predictable traps that get directly flagged in the Cambridge Principal Examiner reports. Warning number 1, forgetting units. Look, it sounds basic, but losing a whole grade because you forgot to write down millimeters will absolutely haunt you. Warning 2, failing to check units and terminology. Mixing up a micrometer and a millimeter when discussing synaptic gaps, that is a fatal error. And warning 3, the one we discussed at the start, writing answers that are not specific to the context given. To lock this in, let's create a custom memory hack right now. Make a mnemonic using the first letters of these key terms: units, terminology, context. UTC. Always check your UTC before moving on to the next question.
Section 4, Interactive Exam Challenge. Okay, pause and predict for a second. What do you think is the fatal error in a typical student's comparative analysis of muscle structures? Think about what Cambridge examiners specifically require when they use the command word compare. I'll give you a second to think about it.
Got it? Well, the fatal error is only identifying the differences. In 9700 biology, comparative analysis strictly requires identifying similarities and differences. And this brilliantly illustrates the divide between an average answer and a top-band Cambridge answer. A flawed answer will just list facts about the neuromuscular junction and the sarcoplasmic reticulum completely separately. But a top-tier answer, that empowers you to grab every single mark by using comparative connectives like whereas and similarly, while backing up each comparison with direct evidence from the provided data. Top-scoring candidates demonstrate true evaluative thinking. They question assumptions, they consider different perspectives, they draw conclusions, and they always justify their decisions with solid evidence.
Section 5. Final takeaways and the hidden cause. So, we've mapped out the structures, we've installed the method mark strategy, and we've checked our UTCs. But fixing these errors really only solves half the puzzle, which brings us to a massive, unresolved mystery. Which specific command words instantly decide your mark band in a 9700 exam? Because here's the reality. If you don't know the exact difference between explain, describe, and evaluate, examiners literally cannot legally award you top marks no matter how good your science is. The true hidden cause of lost grades lies in decoding these command words. So to crack the command word code, make sure to subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS right now, and I will see you in the next explainer.